Alrighty, in this video we're just going to go over the practice test. That should say not Chapter 5 test. This is actually the practice test. And so many of my students are going on the band trip. They're going to miss this in class and they're going to come back on Wednesday and have to take the test. So go over this video to sharpen your skills on exponents and logarithms. Just like the real test, 10 questions. The same type of questions, the same number of questions. So if you know the concepts, you will be fine. Number 1, evaluate the function at the indicated value of x, round decimal or round to 3 decimal places. So f of x is 30 to the x power. So of course f of root 3 is going to be 30 raised to the square root of 3 power. So let's jump on the calculator and do this. On the TI-89s we would use the up caret key and use the square root of 3 as our exponent. This is going to be a little different. We're going to punch in 30 and then the y to the x key, or x to the y key. So now we have 30 and we see our up caret here in the display. We want our exponent to be square root of 3. So 3 square root, it says 30 up to the square root of 3 power. There's the square root of 3. So we hit equals. And we get approximately 361.784. 361.784. Number 2, use the one-to-one property to solve the equation for x. So we got to get our bases the same. This is 3 to the power x plus 3 equal to, we want to write this as a base 3. So we'll start in small steps. 1 over 81. 81 is 3 to the 4th power. And to bring that up top, to bring that base and exponent up, we reverse the sign of the exponent. So that's going to be 3 to the negative 4. Now we can use the one-to-one property. The bases are the same, so they can be ignored. X plus 4 equals negative 4. Subtract 4 from each side. Ooh, and I made a little boo-boo there. That was x plus 3. Why did I change it to an x plus 4? This is supposed to be a 3. That's supposed to be x plus 3 equals negative 4. X plus 3 equals negative 4. And we subtract 3 from each side, and we get x is negative 7. Number 3, write the exponential equation in logarithmic form. So we're going to have the log of some base of some number is equal to some other number. Well, this is an exponential, and the base is 3, and the exponent is also 3. This base goes right here, log base 3, a small subscript 3. The exponent hops over to the other side of the equal. 3 is over here, and our 27 goes after the log. Log base 3 of 27 is equal to 3, or 3 to the 3rd power is equal to 27. Use the one-to-one property to solve the equation for x. So we have the natural log here equal to the natural log here. Well, the one-to-one property says, since those logs are the same, we can set 2x minus 1 equal to 11. And of course, we'll add 1 to each side. 2x equals 12. And we'll divide by 2 and get x equals 6. Number 5, condense the expression of the log into a single quantity. So we have a log base 6 and another log base 6. The first thing I would address is this coefficient 2, that we can move up top and make that a z squared. So we have a log minus a log. When we condense a difference of logs, we're going to have a log of the same base 6. But now we're going to condense what we were logging here, y and z squared. And when this is a subtraction, a difference of logs, it becomes a quotient. Our numerator is the first quantity. Our denominator is the second quantity. Y over z squared. Log base 6 of y over z squared. Number 6, solve for x. This was a lot like one we saw a little bit earlier, but except this base 6 is different. So we have 6 to the x equals 1 over, well, how do we rewrite 216? That's 6 to the 3rd. Bring the base and exponent up and change the exponent's signs. 6 to the x equals 6 to the negative 3. Oh, and that's a done deal then. Bases are the same, set the exponents equal. X equals negative 3. 7. Solve for x. The ln of x equals negative 1.6. Well, if we're solving for x, we got to spring that x out of the natural log jail. How do we get the x away from the natural log? We exponentiate each side to the natural base. E to the ln power cancels, so we have x equals e to the negative 1.6. And let's see if we can do that on the calculator. So we have our inverse key. Where is the exponentials right here. Let's see, we want our exponent to be negative 1.6. 1.6 negative, and we're going to raise that to, inverse. Clear. Where's clear? 1.6 negative inverse e to the x. And there we go. 0.20, and let's round it off there, 0.202. 0.202. X is approximately 0.202. Number 8. Solve the exponential equation algebraically, round your answer to 3 decimals, show all your steps. So we have an e to a power equals 25. We want to get rid of that e, so we will natural log each side. The natural log of e to the 3x equals the natural log of 25. The ln of e cancels, so we have 3x equals the ln of 25. And then, of course, we're going to divide both sides by 3. X equals the ln of 25 divided by 3. So 25 natural log divided by 3 equals 1.073. X is approximately 1.073. Number 9, solve the logarithmic equation algebraically. Round to 3 decimals, show all your steps. So let's see here. What should we do first? We could, if we wanted to go this route, divide by 4. The ln of 3x equals 15 fourths. And then to get rid of the natural log, we're going to raise each side as a power to base e for the natural log. The e ln cancels. So we're left with 3x equals e to the 15 fourths power. And then we would divide both sides by 3. X equals e to the 15 fourths power, all divided by 3. So let's see if we can get this to work on the calculator. I'm going to clear this out. We have our 15 fourths. 15 divided by 4 is 3.75. And we're raising that as an exponent to base e, so inverse e to the x. There's our answer, and now we got to divide by 3. Divide by 3 equals 14.174. X is approximately 14.174. Let's see, there might have been a different way to do this. I didn't think of this here. We have 4 ln of 3x equals 15. See, this way might be harder. I don't know if I'm getting myself in too deep. If I move this exponent up, I will have the ln of 3x quantity to the 4th equals 15. And then we would exponentiate each side. Yeah, this is going to be a little harder. The e and the ln will cancel. We're going to have the quantity 3x to the 4th equals e to the 15th. Yeah, this is going to be a little bit trickier than what we did before. Oop, and I should have had my 4th power outside. So what we could do is do e to the 15th, take the 4th root, and get that answer and divide by 3. But yeah, that is going to be a little bit harder than the first way we did. Number 10, solve the logarithmic equation algebraically, round to 3 decimals, show all your steps. So we got an ln of x minus the ln of 5 equals 4. Before we exponentiate each side, you immediately want to think, okay, I want to base e both sides. But we can't do that until we combine these logarithms, these natural logs. So when we combine, or when we condense an ln minus an ln, a difference of natural logs, we're going to have an ln. And what we do is make these into a quotient. X over 5 is equal to 4. Now we can give it a base e, exponentiate. So these will cancel, and we're going to get x divided by 5 equals e to the fourth. And then we'll multiply both sides by 5. X equals 5 times e to the fourth. Well, let's see, 5 times e to the fourth. Fourth, and we're going to raise that up to a base e. There's our e to the fourth times 5 equals 272.991. Approximately 272.991. And that is the practice test. The real test is coming up. 10 questions, same type of questions. Some condensing, some expanding, and solving for the variable.